Hello everyone, good morning. My name is Robert. I like to present you a project that I've been working on since quite a while, basically since the beginning of the year. That is a development environment for Clojure. Let's have a look. It is called Cloxp, and it is basically focused on allowing development style that is trying to use the features of the Clojure language, the way it represents its internal data structures in a way that it allows you to do really interactive and exploratory programming. So you might ask why we would need another development tool. There are already quite a number out there. So there is, for example, the Cursor tool, of course. There is basically all the tooling built around the Unwrapple support, Cider for Emacs, Vim Fireplace. There is counterclockwise, there is Lighttable, of course. There is Nightcode. So there are already quite a number of tools out there that you can use to get programming with Clojure. And all of these tools, of course, integrate the REPL to one extent or another to do basically live programming to allow you to define new code, new state in your program while you are programming. So why do we need basically another sort of tool that also does that? Well, what I think and I hope to show you that in my talk is that I think we can use really the language features of Clojure, the way, for example, how namespaces, how vars are represented inside namespaces, the ability to instrument code, to inspect the runtime state, to debug things, to figure actually out what the control flows are of our program, that we can actually build better tooling around that. And this is, I think, something that is especially suited to the Clojure programming language, and that it basically gives us a meta-programming interface that allows us to construct tooling around that. So the tool that I want to present here is pretty inspired by Smalltalk, and this is also the reason why this subtitle programming Clojure Smalltalk-Style was chosen. Let me just say this talk is not about Smalltalk. We unfortunately don't have that much time to basically dive in. Smalltalk is actually a very big topic. There are a lot of things to discover around Smalltalk. On the one hand, as a programming language, but also basically about the ideas that were behind that in the first place. So Smalltalk actually was not really a tool built to allow programmers, like really professional programmers, to basically create better products or something. But the goal behind Smalltalk was really what you basically see down there on that picture, to allow personal to basically give people the ability to interact with a computer and to allow them to program. So basically the idea of having kids, maybe a family, gathered around a computer, and not only to consume the things that they are seeing there, but also to create and to author content that they then would basically be able to use. This was actually the idea. And Smalltalk actually was basically just the operating system, the part that would be used to implement all sorts of tools on top of that. And since basically the people didn't really know at that time how to build these kind of programs, Smalltalk was structured in a very flexible way that it would allow basically to change the operating system while you are working with it. And it had basically the ability to create new versions of itself. So these are really some of the fundamental core ideas behind it. And I know that the Clojure community in general is open to old but powerful ideas. And I would really urge you, if you haven't done so, to basically look at what the history basically has there. And for Smalltalk in particular, one good entry point and one really good read is basically the paper that is linked down there. Okay. But for my talk, I actually want to focus not on all of these ideas, but basically just on one specific task, on one specific part of it. And it's really hard to basically describe how it feels to program in Smalltalk. And the best description of that I found up to that point is a blog post by David Buck, and here on the screen you see one excerpt of the post. The entire post is actually pretty good, so have a look at it. Let me just read that one excerpt. As a Smalltalker, you are used to swimming with the fish. You live in the same world as the objects you are exploring. You can reach out and touch them, manipulate them, turn things, and see how it feels. You can go anywhere and do anything. You can go behind the scenes and figure things out. So this might now still sound somewhat abstract and strange to you, but basically the rest of my talk attempts to basically show what is actually meant by that, and I will give some extensive demos to basically show you how we integrated some of these ideas into Cloxp as a development platform for Clojure. All right. So let me get set up here. So what I would like to show you is basically the usage of Cloxp and basically how you start out to work with it, to basically give you an idea of what the workflows are and how to interact with it. So actually we are already in Cloxp. So this here is basically just a web page that starts up the front end of Cloxp. And when you do that, you basically get access to the various tools that you can use in that environment. So in here, the first tool that I can basically start out with is just a normal workspace. The workspace gives me the ability to basically evaluate code. So it's basically a glorified REPL, if you like. So in here I have an expression, and what I can do is I can basically just go ahead and eval that expression. What happens when I do that is that the result of the evaluation is printed down there below the text, and I can then basically choose to either work further with that evaluation result, or I can basically go and do other stuff. So the two things that I can basically do is either insert that result here in my workspace, or I can open up another workspace with a result that then again also has the ability to like evaluate code. So this is really useful when you basically want to inspect certain data structures and you want to continue to work with the inspected things. You can also basically, as most other Clojure development tools allow you as well, get basically go basically quickly to the documentation of things. So for example, when I want to look up the documentation for the plus function, I can just do that here, and then I basically just see what the docstring says. The environment, the code writing environment here in that workspace is basically a full par edit environment in that it allows the structural editing of the expressions in here. So for example, I can like split the expression. I can, for example, select things here based on the structure of the code that I'm looking at. So you basically get all that in this text implementation as well. Now, we can basically look at a little example that we can basically use to get into working with that environment. And one really good example that I like to start out with when I try out a new language is to figure out what is the average size of the code function, for example, in that language. So let's use Cloxp and let's use Clojure to basically figure out what the average size of a function in Clojure is. So this on the one hand gives us some idea about maybe how long our code should be, what is like a good measure for that, and also it basically allows us to learn a little bit about Clojure itself. So the question is, how can we start out? Well, first of all, we need some sort of entry point. So how can we basically get to the source code of a function in Clojure? Well, in Cloxp, what we are able to do is we can actually start and search the system for something that might be related to that. So in here, I will open up a second tool, the browser. And the Clojure browser gives us the ability to basically search the runtime system. So as you were able to see, while I was evaluating that expression, we actually already connected to a Clojure server that was used to evaluate the expressions, and that same server can also be used basically to search the runtime system. On the one hand, search for code, and on the other hand, basically search namespaces and the things that are defined in namespaces, and we are able to basically look at it. So when I search for symbols and I just type something in like source, so this sort of list here gives me the ability basically to see all namespaces and all vars defined in that namespaces, so basically the functions and the other state, and basically just filter down the matching results in here. When I basically search for source, I see a number of matches. And one match that we basically see here is the Clojure REPL source macro. And I click on it, then the code browser actually takes us to the definition of Clojure REPL source. So in here we see on the one hand the docstring for the function, and we also see the actual implementation. And the browser is really structured around that you are basically able to, on the one hand, browse the namespaces here on the upper left side. When you select a namespace, then you can basically see the internals, so the vars defined in that namespace, and then you can drill down to basically see the implementation of that. And then you are also able basically to just to go back and basically browse around your way throughout the system. Okay, so back to the source macro. What we can actually do is can just take the example from source and bring that back to our workspace over here. So when I paste that expression in here and I evaluate it, we actually get an error. The error says that we are unable to resolve the simple source in this context. Just as a tangent, whenever you get an error here, you can actually also look at the full stack trace of that error, and basically all objects, all elements in the UI that you are working with really try to basically give you additional options, browsing, exploring options. So for example, when you look at that sort of stack trace, you can, at least for the Clojure parts, actually still, for example, browse further, and in here I am able to basically click on an element inside the stack and I can see its definition. So basically these things are all tied together thanks to basically the inspection capabilities that we get. Okay, so why do we get this sort of error? Well, in our workspace here, we are actually inside the user namespace. So in here, the source macro is defined in the Clojure REPL namespace, and when we actually use that fully qualified name, then we are able to evaluate that expression and see the result. Okay, great. So let's define maybe a new var. Let's call it source for the result of it. Evaluate that and look at the result of source. It's nil. Why is that? Well, let's look at the output of REPL source filter again. As we see here, the actual evaluation result of that expression is nil. Just the output, basically what gets printed on standard out, is the actual source code that we are looking at. So as a convenience to not just looking at the output of the actual REPL server that you are also able to see in Cloxp, Cloxp will actually capture things that are going to standard out and standard error and present them additional to the value of an expression when you interactively evaluate it. So let's go back and look at the macro source. In here, we will actually see, okay, the reason why we don't really get back a value is actually that the printline function was used. So let's look at the thing that is called a source-fn function that is being called inside the macro. In Cloxp, we are able to basically just jump to the definition of an expression when we have it basically at our cursor. When I try to find the definition of the source function, we basically just use a browser and jump to it. And in here, we actually see that we can also call the source-fn function, and this time basically directly pass in a symbol. So when we replace our query, our expression with z and evaluate it, then we will see, okay, we actually get back a string, and we can basically assign that to the source var. Okay, so now that we have source, one more thing that we have to do basically to figure out what the line length, the average line length is to actually get to the lines. Now it's pretty tedious basically to evaluate things step by step all the time. So one additional thing that we can actually do is we can enable what is called the live evaluation. When I do that, then basically all the expressions in my workspace get evaluated when they are being changed. So now let's look at, we happen to know that there is a Clojure string function for splitting a string into lines. Let's look at it. When I'm typing something that is not complete, I actually see the error here due to the live evaluation feature. And I actually can also get completions for the things that I'm typing here. So in here, when I type CLO and ask for completions of that, then I basically get a list listing everything that has something to do with CLO in it. When I type in string, then I basically see, for example, that I can complete this expression to Clojure string. I click on that, make a dash for basically accessing the qualified, to access all the vars defined, the public vars defined in Clojure string, get the completions again, type in something with line, and then I will see, okay, there are two functions in here. One of them is called split lines. Let's use it. Pass and source, and then we will see, okay, we get basically the result, all the lines. So now we can basically just go ahead and just count them. Split lines, we actually have to do it this way around. So, and then we see, okay, we got 20 lines in that function. So the two remaining parts that we actually still need are, given a namespace, we need all the vars, all the function in it, and this can be done using the NSInterns function. So NSInterns, given a namespace, for example, Clojure.string, actually hands us back a map with all the vars, and if we ask for the keys of that map, we basically get the names of all the function other vars defined in that namespace. And then basically the next step, when we have that, we actually want to have all the namespaces defined in the system, and this can simply be gotten at with the all-ns function that we can use. Now it's pretty tedious to basically go through all the entire steps in writing that code. I don't want to do that right now, but this actually gives me the ability to show you how to integrate other kinds of projects inside Cloxp, because I actually already have written a very small Clojure project that basically counts the lines of code using the things that we see here in that workspace. Okay, so how can we use it? So first of all, what we want to do is we can go back to our Clojure browser, and in here we are offered to load a Clojure project. Clojure project in the end is basically just a directory that can either contain like a POM XML file or a project CLG file that basically defines a project. In here, let's navigate to the Clojure demo metrics project. I can choose that directory, and when I accept my input, then I'm basically offered to load all the namespaces that are defined in that project, which right now is just one, the Clojure metrics namespace, and I accept that. Then my browser basically directly takes me to that. So in here, I have a couple of functions defined using the things that we have seen before, and I can then basically just go ahead and use those into my workspace. So in here, I just import the functions to actually use them, and then as an example, I just enumerate like the namespaces for the beginning. Just take 4 of them and then basically count the lines and put them into an average function, which basically gives us this result. It's actually converted into float. Do it again. And then we will see, okay, for those 4 namespaces that we have here, around 7 is the average line count. Let's actually run it on all. And let's define z into lines, a new var. So this will take a few seconds until it finishes. So in here, we have now basically our result. And so the answer basically to the question is that at least for the namespaces that are currently loaded inside the runtime environment that we are connected to, the average line count of a function is basically around 10. Okay, so now this result is pretty dry. Maybe we can spice it up a little, for example, by creating a very simple visualization. So there is the Encanter project, right? And let's basically just load the Encanter project that allows us to do visualizations of data inside of our environment here. So one integration that we actually have is the ability to browse projects published in the Clojure's repository. So when I open up this browser, and type in visualization, something like that, visualization, then I will actually see all the projects that have something to do with visualization. And one of them actually is Encanter. And I basically see all the versions that I have available to install here. And I just install one version. The newest version actually doesn't work for me, so 1.5 should be fine. I install it, and without basically having to restart my my environment, my server, I can just continue and use that. So let's use this little snippet here. Paste it into our workspace. And let's actually also get to the actual line counts. So here we replace that var with line count and evaluate it. Oops. Evaluate it, and this gives us actually a sequence actually of the numbers of the line numbers for each the average line numbers for each namespace. When we have that, we can, for example, create a very simple diagram showing the frequencies of those line count numbers. So I will just require the Encanter namespace into my workspace, and then basically just create a data set that will then allow me to create a scatter plot of this data. So when I do that and evaluate it, then in the background we actually should see basically the distribution of the data. So here on the left we basically have the frequency for certain counts. So for how often a certain number of lines, average lines of code was shown, and then we basically have the line count below here. So we see that basically there's a fairly wide distribution to observe. And this is basically just to show you how to integrate existing projects into your workspace. Okay, so now let's move on to the next thing, that we are able to see of actually how to write code, how can we actually use the Cloxp environment to also like interactively like debug code to like really understand what is going on. It's a very simple example. One feature that I want to show you here is basically to be able to install watchers, to install expressions that observe the data flow of expressions inside your code. Here I have a very simple function that basically just takes an argument and does something with it. I can basically move to that expression and observe, for example, the result of a certain sub-expression defined in that function. So when I select that expression here and I install what is called a capture inside that code, and then I call that function, for example, with 9, for example, with 10, for example, with 11. On the one hand, I see annotated to the original definition of the code the value that went through, but this sort of support of inspection actually goes a little further in that I can open up an inspector on the observed values, and actually I basically see all the recorded state over time that basically went through that expression over here. And in that workspace, I actually have like really programmatic access again to those values that were there. So for example, when I evaluate this part here of the expression, I'm basically still able to get to the last evaluation result. And then I, of course, can like nest the observed values. So for example, if I also want to observe the value of this sub-expression here and I run this code again, then I'm able to basically see what is going on here. And this is basically not just like a play feature. We can actually really use it in our environment. So for example, when we look back and look at the source function here and want to like really instrument Clojure code, we can look at the source function, the instrument, for example, that little part down here. It's instrument this here. This is basically, we are reading through the source code of a function and we call it again with the filter function. Then we will be able to see all the values that flow through this code. And here we are also able to inspect that. And so these are, for example, just the char values that were used to like read in the source code of the filter function. So you are actually able to basically instrument all parts of your application, not just the code that you are writing, but like really the entire application and all the libraries and all the system level parts of it too. It's really a very handy way for like learning how stuff works. One of the most underrated features, I think, that usually isn't really used outside of profiling is tracing, which gives us another interesting feature to like debug our way through our code and see what is actually going on. So given the Fibonacci function, we are able to trace the entire execution of a function here. So in here, when I trace Fibonacci call with 9, I am offered to basically trace through the function of various namespaces. So in here, I basically just trace through, for example, all the functions defined in user, defined something matching Clojure and my own. And when I do that, I basically get like the real trace of the evaluation of that result. So this is basically just a wrapper around the Clojure trace facilities that we have, but it's actually done in a way that you, for example, can filter through the results, that you can actually jump to the definitions of basically the code that, of the code that was being traced, and you can, for example, get profiling information here. So how often was a function called, how much time did we spend in it. And it is also great basically to understand how code works, what are the core sites, which function is calling what. So in this example here, it's pretty obvious. We can actually improve things a lot when we just use the memorize function with fib, define fib again, trace that code again, and in here we will see when we use the memorize function, code for Fibonacci basically only executed once given a certain input, and we can like easily figure out where the bottlenecks are and optimize those bottlenecks here, given basically the information that we have with the trace. Okay, so a pretty handy feature. Now Cloxp also has some support for Clojure script, and I will not be able to go into too much detail about that, but let me just say there is basically the same support for browsing Clojure script code as there is for browsing normal Clojure code. So we are able to browse through the namespaces defined in a Clojure script project, and we are also able to get basically a REPL integration to runtime, to a Clojure script runtime. So down here, what we have is basically just an iframe loading up a web page, and in that workspace that we have over here, we are able to connect to that runtime. Actually, let me sure that these servers actually started. We load it, and in here I'm able to connect to it. I can evaluate like Clojure script expressions that will actually change it. So why is it meaningful? Well, actually the environment that we are looking at here is like really defined in itself. This is actually basically the most important part that is taken from Smalltalk. And that all the tools that we are looking at, for example, the browser, actually offers its implementation to us. So we were able to basically inspect the Clojure runtime system, but not only that, we are also able to inspect the implementation of the tools. So if I want to see how the Clojure browser works, I'm actually just able to open up a browser that shows me the definition of it. I'm able to go in there to change things and to basically really iterate quickly over my tools and my environment that I have here. So at the current point in time, most of that front-end tooling is actually written in JavaScript. So this is JavaScript code that you see here. But basically using that Clojure script integration, one of the next steps is basically to move various parts of the tooling over to Clojure and Clojure script itself to basically provide a better integration on that level. So this basically leads me to the end of my talk, and I have actually a few more things to show you. So tonight there will be an unsession at 8 p.m. That if you are interested in the project, I would be really happy if you want to attend there. So we will basically have an open Q&A session, and I want to show some more demos about Cloxp in there. If you are interested in like the updates and where the project is going, these are the various links. And yeah, if you're interested, all the project is open source. I would be really happy to have people working with it, trying it out, and maybe also helping along the way, developing various interesting features for it. This basically concludes my talk. Thank you very much.